Let's start our discussion of chemical equilibrium, what it is, and how you can think about it. Let's look at a seesaw, for example. A seesaw without anything on it would not move. You can think of this sort of as an equilibrium. Now, let's suppose we put a girl on one side of it. Would the seesaw be equilibrium the moment the girl sits on the seesaw? No, because there would be movement of the seesaw. We would expect something like this to happen. The girl would exert a force on the seesaw and bring it down. But after it becomes like this, it reaches sort of a new state of equilibrium. And again, let's say we added another object to the other side, like a rock. Would this be an equilibrium the moment the rock sits on the seesaw? No, it wouldn't, because assuming that the rock is much bigger and heavier than the girl, we know that the seesaw would move. In fact, we would expect something like this to happen. Let's think about whether this situation is in an equilibrium now. And I would say yes, this would also be some kind of equilibrium because nothing is moving again. So whenever you have the potential to move to a different state, you are not at an equilibrium, but once you are at that state, you are at an equilibrium. Now this example isn't perfect for our discussion, but it is a good example. Why it isn't perfect is that chemical equilibriums are dynamic. Let's look at what that means. Water plus carbon dioxide makes carbonic acid. In fact, this is a reaction that some people think will acidify our ocean so much that a lot of marine life in our ocean are going to die. But anyhow, let's just look at this reaction for example. We know that there would be some forward rate, that is, some kind of rate at which water and carbon dioxide goes to make carbonic acid. And we know that this rate would lessen because there will be less of the reactants. So we could sort of model the forward rate, which I have drawn here in purple, as something like this. Similarly, there is a reverse rate for this reaction, that is, carbonic acid would spontaneously decompose into the reactants, water and carbon dioxide. And we know as time goes on, there will be more carbonic acid, so we would expect that the rate of decomposition of carbonic acid to increase with time. And so we would expect to see something like this. From this graph, we can tell that there is an equilibrium. In fact, the equilibrium is over here, where the forward rate is equal to the reverse rate. This is when a chemical reaction is in a state of equilibrium. Notice, however, the forward and the reverse rate are at a non-zero value. That means that this equilibrium is a dynamic equilibrium. There's still stuff happening inside the system, it's just that the forward rate is equal to the reverse rate. Therefore, one very important concept that you should remember is that chemical equilibriums are dynamic.